We will talk about future of the computer science today. Here, it already sounded like we are talking about robots. So let's see one by one. The first thing comes if we want to talk about the future of the computer science is, of course, artificial intelligence. Because nowadays we can see it's working in agricultural, in medical, industry automation, then it has in military world, wars and politics and many more. So it's not only this, but there are many other sections also that actually artificial intelligence taking over. So one of the examples are personal robots in future. So it's already some of the robots you can also see. These are like helping in our daily life or daily house chores. It can bring you uh, a glass of water or make something for you, cook something for you. So it's actually reducing the manpower also and also helping for our daily activities. So, but these robots are designed for a specific task only. It is not ready yet to do all the things that a human wants to do. So these are the examples of some of the robots. Temi, the robot, it has a screen on top of it, and whatever you want to do with, you can search or have some information about anything you want to ask to this robot. It also can move around with the wheels. It has wheels underneath and it can move around with people. The second one is Misty 2. This is a very small robot. This is in also a it's also working now, and also they're developing more version of it. So this robot can actually respond to your audio. So whenever a human is speaking, it can turn to that speaker or the human and listen to what it says. So you can talk to that robot as well. So these are very small features, but still these robots are there doing specific tasks. Talking about self-driving cars, of course, when we drive the car, we have the vision of more like what do you say? We can see the vision with all the mirrors, side mirrors, and the back, and we have like a mirror on top. We can see what is coming in from the back. So human can perceive so many visions and take a decision in a split seconds. But for a machine to work on this, we need cameras it should work like our eyes. So what happens is it needs to detect everything, whatever it sees in the scene. So if you can see in the second picture, this one, you can see it is detecting cars, it is detecting human, then signs of the road or U-turn or left turn. So it has to detect everything in the screen, and then it can map it in a small screen over here, so that the human, whoever sitting inside the car, can also see if it is doing the right thing or wrong thing. And depending on the detection, it can automatically turn the wheels, steering, and then turns the wheels as well, depending on the detection. So whether it needs to stop or it has to go, it depends on the obstacles or detection in front of the screen. So for the self-driving cars, we have some cameras. There are three types. One is situated in the front or at the back or in the side mirrors like this, so that we can have 360 views of all the cameras. Then we have a rudder, that is a sensor. It's situated in front of it, so that it can sense what is in front of it. And we have a lidar, it's on top of it. So this one actually works for providing a shape or depth of surroundings of the car. It works for the low light conditions. So rudder and lidar, these two things actually works for the low light and helps in the night vision. And camera will always help to detect the 360 views. So just think like a human, whenever they drive, they just sit in the driving seat and can do everything that all these cameras doing. So for a self-driving car, we need to have all the views and detect. So it's never possible to have a decision in split seconds like human. So, but still it's working. It's helping us uh, to have driving cars without the drivers, and also whoever cannot drive the car can also afford this kind of cars. So there are two types of robots, AGI and ASI. So AGI is this is artificial general intelligence, and ASI is artificial super intelligence. So what happens is a general intelligence can do a specific task, only one task. Maybe it can cook, or maybe it can bring a glass of water, or maybe it can listen to you and talk back to you, just one task. For ASI, it can do multiple tasks. So, but recently we don't have ASI, don't have much ASI, but have specific robots. Robots doesn't mean like it has to have a human kind of shape. It can be anything. It can be on an arm, it can be a monitor, anything, and we can call it as a robot too. So if we talk about robots, we need a machine vision system.
You
What is a
repeat the difference between AGI and ASI again?
Yeah, sure. So AGI is for general intelligence. It means it can do a specific task, only one task. Maybe just playing music or talking to you, or maybe doing a specific task like bringing something to you, or following your commands. And ASI can do multiple tasks, like a human being can do multiple. Maybe can do cooking and reading books, etc. Is that clear?
ম্যাম ম্যাম তাহলে কি চ্যাট জিপিটি এজিআই?
ChatGPT can be, yes, because it's only giving you a text-based reply.
ম্যাম এএসআই যে বললেন মাল্টিপল টাস্ক করতে পারেন, মাল্টিপলটা কয়টা? একটা, দুইটা, কয়টা? একটা নাম্বার কি
Multiple means
ফিক্সড আছে
like
নাকি?
no, number fixed name, more than one. Could be 2, 3, or could be 10, 12, but not এখানে কোনো ফিক্স নাম্বার নাই। বাট অনেক কাজও এখন রোবটসরা এত বেশি কাজও করতে পারে না, মানে হিউম্যানদের মতো। there is some constraint.
Yes, I understand. Thank you.
Okay, all right. Any question on this? Okay, so AGI
মাল্টিপল টাস্ক বলতে হচ্ছে এসআই হচ্ছে যদি দুইটাও কাজ করে, এটা কি কি হতে পারে? মিস একসাথে দুইটা বা তিনটা?
সেটাকে আমরা বলতে পারবো যে ও মাল্টিপল টাস্ক করছে, নট লাইক অনলি ওয়ান টাস্ক।
জি মিস, ওটা এক্সাম্পল যেমন আমরা বললাম যে টেক্সট বেসড হচ্ছে চ্যাটজিপিটি, তেমন এইটা একটা টাস্ক। বাট এসআই ক্ষেত্রে যেহেতু মাল্টিপল টাস্ক, ওইটা কি মানে স্পেসিফিক্যালি কি কি মানে তাও হতে পারে, মানে টেক্সট বেসের সাথে আর একটা টাস্ক কি অ্যাড করতে পারে, এরকম জিজ্ঞেস।
আরেকটা ফিচার অ্যাড করতে পারি চ্যাটজিপিটিতে, যেমন ধরো টেক্সট বেসড রিপ্লাই এর সাথে সাথে যদিও আমাকে একটা ডকুমেন্ট ক্রিয়েট করে দিতে পারে।
ও আচ্ছা আচ্ছা, থ্যাংক ইউ।
রাইট, অথবা ধরো শুধু টেক্সট বেস, সেটাতে তো আমাদের টাইপ করতে হয়। যদি আরেকটা ফিচার হয় যে আমরা কথা বলতে পারি আর সেটা অলরেডি টাইপড হয়ে লিখে নিতে পারে, তাহলে সেই ক্ষেত্রে চ্যাটজিপিটি কাজ করবে, মাল্টিপল টাস্ক হিসেবে কাজ করবে। জাস্ট মোর দেন ওয়ান টাস্ক কুড বি called ASI. Okay, so coming back to machine vision is a process where it is used in multiple industries. Many industries, they are using machine vision to automate their productivity or automate their systems. So we will talk about what is it actually. So the process of extracting information from visual sensors, it is called a machine vision. It means like if you have a camera and you take a picture of that scene and you can analyze what is inside. Could be a detection, tracking, or analyzing, recognition, etc. So for a machine vision, we need some components like light source, of course. Without light, we cannot take a picture. Could be a night vision system as well to take a picture. We have lens like telecentric or macro lens. We would have sensors, and we have two units like vision processing unit and communication unit. So you can see the concept of a machine vision over here. So there is image acquisition, where the sensor and optics and lighting works in image acquisition. It means like you take a picture. How are you taking a picture? With a sensor or with some lighting or with a flashlight? So whatever you're taking it, it's called the part of image acquisition. After taking it, we need to analyze what we are working with. So here are the components or the software or algorithm we will be using to analyze the image that we have already taken. And last, we will have the communication unit to have the result. So this is the part where we integrate the application. We take the image, we analyze it, and we give a result here. So this is a fully automated system of a machine vision. So I'll show you some examples later on. So what is the principle here is we have step-by-step process in it. So the first step is to take a picture. Second step is to analyze the characteristics of the picture with the visual data or make decision of the image analysis. And the third step is to communicate with the user end. So could be if it is used in industrial process, it could be an acceptance or rejection of the product that has been used for the machine vision. So there are two things, machine vision and computer vision. These are two different things. Machine vision can be a small part, but computer vision can be a whole software. So what happens is we can say a computer vision has machine vision in it because it's a small portion that's working with it. But we cannot say machine vision is a computer vision. So I'll show you why we are saying it. So here's an example of an industrial process to make some products. So this is the line where the products are coming in a tray one by one. And from this product, we need to check if it is a good product or it is a defective product. So if it is defective, we should get it out of the production, right? So this thing's going to come one by one. And here we have an inspection sensor and decision sensor. All these are taking pictures of this products individually and trying to analyze it. So the first step, as we talked about, we take a picture. And the second step is this one, when we analyze it. So this is a very unique camera. This called BOA smart camera. BOA stands for Ballet of Algorithms. It means it is a smart camera, very small size, but it has algorithms based on the industrial production. So this camera can detect or analyze the pictures and can give the result and have a decision. So processing of these two things, we can take a decision. And here is the reject kicker. It means like whenever the product is coming one by one, after this decision sensor, if the product is wrong or defective, we can just kick it out of the tray so that the next product can come here and then have the decision. If this does not kick it out from the tray, it will go to the good product list anyway. So this is one example of a machine vision inspection technology, right? So it can do for thousands of products without any fatigue, where if a human has to do it, they will be very tired after like few numbers or such numbers of productions, right? So these techniques can automate an industrial analysis or the production. So machine vision.
Ma'am, to explain the computer vision, could you explain it again, what a computer vision is?
Computer vision is a small part of the whole industrial system. Like, just look at this example. We are only taking this product and then having a decisions over here. So this is a small project for just rejecting defective items, right? So this is small part. But if we talk about like after this we have another system which is also based on camera and trying to package these good products. So what happens is from start to end, if we use all of it with a vision system, we can say that is a computer vision. The whole process is computer vision. But if we only use this kind of things for only one set of tasks, we can say machine vision. Does it answer your question?
Yes, ma'am.
Okay, all right. So these things are machine visions are now used in everywhere, and from if we can see the revolution going on in industry, it started with 1.0 where we had like all the machines with powers and mechanization. Later, the next version of the industry level, they added like electrical or energy or mass production systems. Later in industry 3.0, we had automation, some electronic devices and components. And nowadays, some of the industry are very, very well designed with artificial intelligence and also machine learning. So here they have added like cyber physical system, Internet of Things, and we have cloud computing, cybersecurity, and etc. So this is the revolution going on from industry 1.0 to 4.0. So there are many applications of machine vision. Of course, it can be used in automotive, which could be like self-driving cars and all automated systems. There are many electronics that are working with artificial intelligence, like face recognition system for securities, door cameras, etc. We can use in food. Nowadays, there are many machines you can just order by clicking and on it, and then it can produce it for you. Then there are many manufacturing productions and industry packaging. No, people don't need to do one by one packaging. It can do it together. There are pharmaceuticals. Drugs can be made automatically. All the chemicals components will be given beforehand, and then it can do it from start to end process, all automated. Mining also. Previously, mining was very dangerous thing for humans. Nowadays, there are drones that can go deep under, and then it can also do things that people cannot reach. There are dangerous gas and all the things under the ground, so people don't need to go. Some of the companies, they send drones and then see what they can do with the mining. So applications of machine vision are very, very vast. Not only this, there are many usage people are doing right now. And there are some more examples we can see for machine vision system, like for industry. If we talk about measurement with using camera, so for to measuring bottles cap, we can use machine vision. So take a picture of a bottle, subtract the background. It means like just to have the area of the bottle like this, subtracting this black color is the background that is already subtracted, and we can measure this kind of bottleneck or the cap. So there are many companies, they have different design of the bottle to have the same standard. Machine vision can have a defective bottle out of this production, and also have a very specific or very accurate measurement of the bottles. Another example could be counting. Like if we want to, if industry wants to create something metal, a metal product, and they need to count how many holes it should be having in that metal. Like if you think about the screws, when you are trying to use any devices, have to screw it, it should have a very specific screw to screw it. So you cannot, if one is missing, you cannot do, or you cannot screw or unscrew that device. So it's very important to have a have this holes counting while in production, so that nothing should be going missing. For this kind of, also for packaging, if any bottles it can also detect while counting. So from taking a picture, it can already count and see if there's any missing bottles while packaging. Sometimes there in the industry, there's sometimes malfunction happens. So maybe one bottle could not get into, or maybe was very hardly kicked out from the system, so it could not get into the box. So this counting, using the machine vision can help and reduce the work for human. Here, if you think about other metals, like it should have a very proper or precise location of the design. It should also can locate using taking a picture. So these are very good applications, of very specific application for machine vision systems. There are many more, like decoding. Nowadays, you can see this kind of barcode scanner in every shopping or any industry levels, to have the counting or the information of a product. So we can have barcodes. Do you know any other kind of codes that we decode in the shops? Did you see?
Yes, ma'am. Bgosh, and then
Okay, those are the company that uses this kind of codes. These are called QR code. Any other code you saw?
And barcode?
Barcode.
Yes, barcode. That looks like this one, right? Looks like this one. Any other code? I didn't see any. Used in Bangladesh.
এই দুটোই
So,
সবচেয়ে বেশি তো আর দেখা
Exactly. These two are the codes mostly used. Okay.
Miss,
Yes.
I'd like to say something.
Yeah.
Miss, there is a power cut problem in our area today, and my phone has only 2% charge. It would be very kind, Miss, if you took my attendance earlier.
Yeah. Okay. I need to share the attendance before. Wait. Just give me some time.
Thank you, Miss.
I can share it in Zoom. So this is a form. You can just put your name, ID, and section and submit it. I will get the attendance anyway.
Okay, Miss. Thank
This is for everybody anyway.
you so much, Miss.
Okay.
Oh, ma'am, I didn't get you. What's the form for?
For attendance, online attendance.
Oh, okay.
Okay, this is for everybody. You just mention your name, ID, and section from there. Let me know if you have any problem with the forms. Okay, going back to this by the time. So these are some of the applications, and the advantages of the machine vision is, of course, this is reliable and there's no fatigue. It can work 24/7, and it's very consistent and performs beyond human visions and many more. So machine vision is very helpful for the automated systems. Now we can talk about AR in surgery and healthcare. AR is augmented reality. You can we will see some examples how AR is helping for the surgeries. So there are augmented reality assisted surgery. In short, it's called ARAS. This is a surgical tool that helps the doctors to visualize the operating room about the patients or the area that they need to operate. It could be heart, it could be brain, or any part of the body. So previously in the previous lecture, we already saw that we can take a picture of a hand, and then we can imprint the skeleton on top of the hand to know where the bones are. So this is like in the real scene, we are just augmenting the picture on top of it. So that's why we can call it AR system. So this AR system needs, of course, head-mounted device so that doctors can operate and also visualize the area they need to operate at the same time. So the technique has been used or tested in urological and cardiovascular domains right now, but still we need to go, we need to do more on these things. So these are some examples, and these are called OR bots. OR means operating rooms bots. So everything is digital over here, and people uses head-mounted device, and then they can have the 3D view of the surgical process. So if a patient is lying over there already, they can have the augmented reality and check for all the parts of the patients and of the surgical area. So this helps to develop and also to ease the doctors' long-term surgeries.
Miss, what was the abbreviation of OR?
Operating room bots. Okay, so there are many more examples like this. So you can see also in a meeting room, we can project some of the 3D views of the surgical process, and people can have a meeting in the table and then talk about it. All the doctors can sit together and talk about it. So these examples are some other examples are there also. You can check all these softwares and go through how does it work if you're very interested in it. You can see this one also. This for while doing the surgery, we can have the X-ray vision on top of the patient and can locate where to actually do the surgery exactly. So no need to cut open all the parts. We can already have the view where the surgery area is located. Here are also some of the other examples. These are some of the softwares you can go through and take a look. How does it work? This is Microsoft Augmented Reality. So these are helping all the doctors and surgeons in the operating room and trying to have less time and research at the same time while doing the operations. These are some more examples, same kind of examples. Everybody wearing head-mounted device, and then also have all the vitals showing on top of it. But we have some limitations because we cannot rely on the robots fully. Of course, we have to have expertise to know that if the surgical process is going right. So there are many robots, robotic arms also that can do the stitches that I told you in the last class. Like doctors can reduce their fatigue if there is like a long-term surgery going on, they feel very tired at one point. So they monitor the robotic arms and do the stitches and then look for that if it is doing right or wrong. So of course, the data so far generated in AR are not substantial. We need to modify and we need to work on it more and more. And also, whenever we have the AR or the picture of organ, it's very rigid, but human organs are not rigid. Maybe the patient has some other formation, but the picture that is shown is searched from the web or the standard form of the organ. So we need to have expertise in these cases. We just cannot rely fully on the automated AR system. And now if we talk about IoT, you know about our IoT, Internet of Things? Anybody has any idea? No? Okay.
Ma'am.
Yeah?
No, ma'am.
No, okay. So Internet of Things are the smart things that you have in your home. You can have maybe an automated system or assistive system. Anybody has Google or Alexa in their home?
Almost everyone.
Almost everybody has Google assistive system, the small one, not the phones. I'm talking about the assistive system, like the device that you can
No,
talk.
ma'am.
No, not
No,
everybody.
ma'am.
Right. So you should get one. It's very cheap, not that expensive. You should get one. And why am I saying this? Because not to just to talk to it, it can do several things in your home. So you can automate
Ma'am, it's
your.
spice. It listen to our conversation. That's why.
You can mute it if you don't want it to listen it, hear your conversation. But it can really automate your rooms. Like in my home, I have aquarium, and that aquarium has like natural plants in it. So what happens is it needs lights for 6 hours. I don't want to turn on the light every day at the same time, and then I have to turn off the light every day same time. So what I did, I had a smart switch connected with the Google Assistive Systems, and then I
And automated.
automated the time, like every day 6 p.m. turn on, every day after 6 hours turn off. So it does it by its own. So
Ma'am, I had a similar switch, but it burnt off.
okay, burned off. Maybe because of the high voltage system, right?
And because of the IPS problem.
Oh, I see. But these switches are also very, very cheap, not that high expensive prices. And you can also
Yes.
have like smart lights. You can turn it on with your mobile phones and turn it off as well, and automated. And so these are called Internet of Things. So you can have power plug. So you can turn on your phone charger if you are very lazy to get up from the bed. You can have smart light. Whenever you're at home, it should turn on. And how can it know like you're at home? Maybe depending on your location, phone location, or you can have some sensors that can sense already that you are at home. It can have door sensors. Whenever you're in front of the door, it can turn on the lights already. And we have motion sensor. It can give you an alert already if there is something like doubtful going on outside. So these are some of the smart switches or smart things that you can make your room automated. At least start with your room. I would always suggest you to buy at least one smart system for you, at least one light that can also, like if you play music, it can also change the light depending on your music rhythm or beats. Did you see any like that smart light?
Yes, ma'am. LED lights.
There
LED
is
light.
Philips has the smart lights.
LED strip lights.
I have
Yes.
one.
RGB strip lights যেটা।
RGB,
But
RGB.
there's Yi light as well. There's a thing called Yi light.
E-light. Okay, yeah. These are very simple thing, but it already makes you feel like you have automated things already. So what happens, what I did, I also did something like that automation. Whenever I'm in a range of my home, it should turn on my AC, it should turn on the lights, and it should welcome me whenever I'm home. So these are automated things. It's really fun. And also in the morning when I say good morning, it should greet me back, and also it should start playing news so that I can know what are the headlines are. So just imagine, like, it's already doing so much for you. So you should at least have a smart plug. Buy one smart plug and do, maybe you just try to turn on your lamp with it. And what interesting is this can be used with your mobile phones, right? So you can give access to your family members or friends. So if you want to talk to your friend with the signals, you can turn on and off their lights without even asking them. Just think, like, if you want to play with them, you can do that too. So gift somebody a smart light, and then you play with your application from here. So it's really fun. So these are called IoT, and it is about the evolution of IoT. So previously we had like fixed line telephones. You remember the era that we had to dial the connections and talk with a land phone? Anybody has land phone still at their home?
I have
No, ma'am. ছোটবেলায় ছিল।
জি ম্যাডাম।
Ma'am, I
এখনো
have
আছে।
as a selfie.
সেটা 3 বছর আগে জিজ্ঞেস করলে ছিল।
এখন আছে ম্যাম ইন্টারকম।
Right. Intercom শুধু মনে হয় ইন্টারকমই আছে, এক্স্যাক্টলি। আগে ছিল ল্যান্ড ফোন, যেটা দিয়ে কথা বলা যেত, এবং ল্যান্ড ফোনটাও আবার ইয়ে করা যেত, কানেকশন প্যারালাল করা যেত, রাইট?
ইয়েস
So
ম্যাম,
madam.
ছিল আমাদের বাসায় আগে।
একসাথে দুই রুমে যদি কথা, মানে একসাথে যদি দুইজন ফোন উঠায়, তাহলে একজন একজনের কথা শুনতে পারবে, এরকমই ছিল।
ইয়েস ম্যাম,
that's free
মানে এক ঘরে কথা বলতো, আরেক ঘরে শুনতো তুলে।
জি ম্যাডাম,
Exactly.
এরকম অনেক করছি ম্যাডাম বোনের সাথে।
রাইট। এগুলো দিয়ে ব্ল্যাকমেল করা যায় নাকি বোনকে?
জি জি
একবার
ম্যাডাম।
মারও খাইছি এটা করে।
Yeah, that was fun. Pre-internet time was very fun. Then we had this email and www. Remember, we had dial-up connections of internet. Anybody has it? Had like কেউ কি এটা কখনো পেয়েছো? ডায়াল-আপ কানেকশন, ল্যান্ড ফোনের সাথে ওটাকে কানেক্ট করে ডায়াল করে তারপরে ওয়াইফাই কানেক্ট করতে হতো।
ম্যাম তখন টিভি দেখেই জীবন কাটতো, এগুলা ছিল না।
আচ্ছা, আমাদের একটা ছিল এরকম, ফোনের সাথে কানেকশন ছিল, ওটা ডায়াল করে কানেক্ট করতে হতো ইন্টারনেটের সাথে। ওই টাইমে যদি কেউ ফোন করতো, এঙ্গেজ আসতো, তাহলে বোঝা যেত যে আমরা ইন্টারনেট করছি অলরেডি। আর কানেকশন এত স্লো ছিল, বলা বাইরে, কিলোবাইটে ছিল কানেকশন। এখন তো মনে হয় মেগাবাইটস আর মেগাবাইটস, হান্ড্রেডস অফ মেগাবাইটস।
তখন এই কিলোবাইটস দিতে এখন আর 5 মেগাবাইটস এর থেকেও বেশি স্পিড মনে হইতো।
এক্স্যাক্টলি। বাট একটা ওয়েব পেজ যখন লোড হতো, একটা একটা করে লাইন লোড হতো, এরকম 1 2 3 4, তারপরে পুরা লোড
But
হতো।
that was fun as well.
Right. And then we had Internet of Services, e-commerce start হলো। E-commerce means আমরা শপিং করতে পারলাম, একটা করে অনেক রকম সাইট আসলো অনলাইন, সেটা দিয়ে আমাদের Internet of Services start হলো। After that, we had Internet of People, which is still going on, which is a social media, YouTube, TikToks, and everything. And lastly, we have Internet of Things. Right now, the hype is machine to machine or automation. So এমন জিনিস হয় যে আমরা অটোমেট, আমাদের হিউম্যান টু মেশিন হতে পারে অথবা মেশিন টু মেশিন হতে পারে। সো সাপোজ, যেমন আমি বললাম যে আমি যখন বাসায় আসবো তখন যেন লাইটস অন হয়। সো এটা কি হতে পারে? অবশ্যই আমি আমার মেশিনে সেট করে রেখেছি, আমার মোবাইল মেশিনটাতে সেট করেছি বলেই সেটা লোকেশন অনুযায়ী অন্য আরেকটা মেশিন স্টার্ট হচ্ছে। সো এই জন্য এটাকে আমরা মেশিন টু মেশিন বলতে পারি। আর যদি বলি হিউম্যান টু মেশিন, সেটা যেমন হতে পারে যদি মোবাইল ফোনে একটা বাটন ক্লিক করলাম, যে এই বাটনটা ক্লিক করলে অটোমেটিক নিউজ পড়া শুরু করবে, একটা অ্যাপ্লিকেশন খুলে নিউজ পড়া শুরু করবে, সেই ক্ষেত্রে হিউম্যান টু মেশিন হতে পারে, যে হিউম্যানটা ওই বাটনটা ক্লিক করেছে বলেই ওটা স্টার্ট হয়েছে। So there are many more, but I would like to stop here because there are many more examples coming in. So today we are going to stop here. Any questions you have until now?
No, ma'am.
ম্যাম, ওয়েব 3.0 সম্পর্কে আপনার মতামত কি? এটা কি আদৌ সাকসেস হবে নাকি ফেল করতে পারে?
ও, সেটা তো আমি একটু রিসার্চ করে বলতে হবে, আমি ওই সম্বন্ধে আসলে বিশেষ একটা নলেজ নাই, বাট আই উইল গেট ব্যাক টু ইউ আফটার দ্যাট।
ম্যাডাম একটা আউট অফ টপিক কোয়েশ্চেন করি।
হ্যাঁ, বলো।
আপনি ক্লাসে যে একদিন আপনার যে রিসার্চ নিয়ে কথা বলছিলেন, তো
হুম,
ম্যাডাম আপনার রিসার্চ কি এই যে এমভি সিভি এইসবও কানেক্টেড?
হ্যাঁ, রাইট, এক্স্যাক্টলি। আমার রিসার্চ হচ্ছে কম্পিউটার ভিশনের উপরে সম্পূর্ণ। সো আমি ক্যামেরা দিয়ে মানুষের অ্যাক্টিভিটি রিকগনাইজ করতে পারি।
আচ্ছা ম্যাডাম, একটু ভয় লাগলো বাট ম্যাডাম জি ঠিক আছে।
না, না,
What
ম্যাম, আপনি কি ব্ল্যাক মিরর সিরিজটা দেখেছেন?
ব্ল্যাক মিরর না তো।
ব্ল্যাক মিরর সিরিজে এরকম কনসেপ্ট আছে, মানে ক্যামেরা দিয়ে ফুল টাইম মনিটরিং করা হয় আর কি প্রত্যেকটা পার্সনকে, এন্ড কেউ কোনো খারাপ কাজ করলে তার রেটিংস কমে যায়, আর যাদের রেটিংস কমে যায় তাদের